Hello, everyone. Welcome to this Math 60 video lecture. This is section 4.3, which is solving systems of equations using a process called elimination. So we've talked about the graphical way: quick, accurate, easy. Quick, accurate, easy. We've talked about the substitution way, which is breaking a complicated system into simpler parts, which is an important idea, not just in mathematics, but in a lot of different areas. And now we have elimination, which the best I can say is a highly specialized tool. So any of you who work on cars or maybe do baking or sewing or something like that, you're going to have some kind of highly specialized tool. I work on, for example, I do my bike maintenance, and so I have a wrench that's used just for my pedals. It's called a pedal wrench. It works really well on pedals. It doesn't work very well on anything else. When I cook, I might have a frosting spatula, right, for putting frosting on a cake. Works really well for frosting a cake, doesn't work very well for anything else. The elimination method is highly specialized. It's a great tool for a very narrow set of systems of equations. Otherwise, it doesn't work very well. Use a different method. So here's an example where it works well. I'm going to go back to that first one I showed you a long time ago. X plus y equals 3. X minus y, y equals 1. We solved this a number of ways. And here, it shouldn't even be called the elimination method. It should be called the addition method, but I didn't get to name it. It's as simple as this. You take your first equation, you take your second equation, and you add them vertically. X's add to x's, x plus x is 2x. Y's add to y's. Y plus negative y goes away. I've eliminated the y variable completely. 3 plus 1 equals 4. My new equation, which I got through adding, has eliminated the y variable. Because x plus x is 2x, y plus negative y is 0y, so you don't have any of them at all. And all of a sudden, I'm just solving 2x equals 4. If 2x equals 4, then x equals 2. And then I go back and I say, well, 2 plus y equals 3. All right, I go back to my original one, so y must equal 1. The elimination method works, is a good tool, right? It's the perfect tool when one of the variables is opposite in the equations. If you don't have that, grab yourself a different tool. So here's another example where it works well. Let's solve the system 3x minus 7y equals 36, and x plus 7y equals 12. I know I could graph these. I could do a substitution. It'd be pretty easy to solve for x in that second equation and then substitute it into the first. But because one of my variables is an opposite in the equations, I'm going to use elimination, right? It's time to change my bike pedals, so I'll grab my pedal wrench. It's time to frost the cake, so I'm going to grab my frosting spatula. Because in this case, it's the right tool for the job. 3x minus 7y equals 36. X plus 7y equals 12. And I just add vertically, so I get 4x. Those two terms cancel completely, and 36 plus 12 is 48. These are nice, simple equations to solve. X must equal 12 because I divide both sides by 4. And now I can go back into either of my other equations and say x plus 7y equals 12. And x was 12, so 12 plus 7y equals 12. This one worked out a little strange because I'm actually going to get 7y equals 0 and y equals 0. You don't always get that y equals 0, but what you do get when you eliminate is a very simple equation to solve. All right, here's an example where it's not a useful tool. Let's solve y minus 3x equals 17 and 2/3 y plus 7x equals 4. Now, if I could add these two equations together, but it would not eliminate any of my variables. So it wouldn't give me a simple equation. Let's just try it just for fun. Let's add them together. I'm going to get y plus 2/3 y. That's 5/3 y. And then minus 3x plus 7x is 4x. And I get a brand new equation, but it still has two variables in it. This didn't help. All right, that's like trying to mix your cake ingredients with your frosting spatula. It's just not the right tool for the job. I could do some extra arithmetic, and I could take that y minus 3x equals 17 and the 2/3 y plus 7x equals 4, and I could turn this equation so that it gives me an opposite. I could say, well, if y minus 3x equals 17, then 3 over 7 times 2/3 y plus 3 over 7 times 7x plus 3 over 7 times, or equals 3 over 7 times 4. That's a version of my second equation. And so doing some arithmetic, I'd have what, 6/21 y plus, those cancel, and there's my plus 3x. Equals 12/7. But this is a lot of work. If I'm going to do this much work, I might as well just do the substitution method. There's a nice equation that would be pretty easy to solve for y, and I'll grab my substitution tool instead. So the elimination method is a highly specialized tool. And this is an important idea in math as well, is sometimes we have really good tools that work really well for a narrow set of cases. And it's good to know those tools. However, they're often not so helpful. Substitution, this is like a multi-tool. It works pretty well in any case, no matter how complicated. Might take a little more work in cases where elimination is fast, but it's always going to work. You know how to use it. So I would say get very good at this, at using substitution, and don't worry so much about elimination. You might see it once in a while come up, and that's when you grab that tool. And graphing's the best. Graphing is like calling your mechanic or going to the bakery, right? You're using an expert. You're using Desmos, which is an expert at solving these equations to make your work super easy. Instead of trying to fix my bike myself, I just drop it off at the bike mechanics and they do everything. They have all the tools and all the expertise, and me knowing to use them, well, that makes me a good cyclist. Me knowing when to go to the mechanic, that's pretty important as well. Or if I'm trying to bake a cake for my kid's birthday, maybe I just go to the bakery and get an expert to do it. But again, knowing that it's time to find an expert, that's pretty good thinking as well. In this course, you are always welcome to use graphing. Knowing how substitution breaks complicated systems into simpler ones is very useful. And being able to recognize when there are highly specialized tools, that's pretty useful as well. All right, thanks for watching.